Talk about the transformations of quadratic graphs, and we're going to look at some different forms of our quadratic equations. Previously, we've talked about the standard form of a quadratic equation, okay? And we looked at the parent function of standard form, and really, this is the same thing as it is standard form because it's a 1x squared plus 0x plus 0. Okay, and as you know with the zeros, we don't necessarily write there for the b and the c. And when it's a 1 out in front, we don't necessarily have to write that either. So the parent function is technically in standard form. Okay? And up here on the screen, oops, I have the graph of the parent function. And if you can see that, if you look closely, the vertex is at 0, 0. It's right at the origin. The axis of symmetry goes right through the origin as well. Okay? The new thing we're going to take a look at today is this one called vertex form. And it's right down there at the bottom. Okay? It has 3 distinct letters in it. There's an A, an H, and a K. Okay? And technically, the parent function is also in vertex form. Okay? And I could rewrite that as this. It'd be y equals 1 times x minus 0 squared plus 0 again. Okay? The A is a 1, the H is a 0, and the K is a 0. And again, with the 0 here, I don't need it. Well, x minus 0 squared is just x squared. And then there's the 1 out front, which we technically don't need. So it's really the same thing, just a different form. Okay, but what I'm going to do here for the next few minutes is I'm going to take a minute and try to see what effect does each of these letters have on the graph, okay, of the parent function. And I'm going to mess with h first. Okay, so I'm going to look at this equation. I'm going to let a be 1, and I'm going to write x minus 2 squared. And again, it's going to be plus 0 for k. So I'm going to leave that one alone. So I'm just going to be looking at the equation y equals x minus 2 squared. If I go to my calculator, and notice how the h is inside the parentheses, so it has to be x minus 2 squared. And if I graph that, you can see there, it's shifted it to the right. Okay, instead of the vertex being at 0, 0, now it's at 2, 0. Okay, so that x minus 2 went to the right 2. Okay, what if I had this in the parentheses? What if I let h be plus 5? Okay, x plus 5. I'm going to y equals, I'm going to change this to a plus 5 squared and press graph. Oops, graph. What that did is instead of the parent function being at 0, 0, it went to the left 5 units. Okay, and we could keep on going and going here, but to make a long story short, the effect that h has on the graph is that it shifts it left and right. So it shifts the graph left and right. Okay, and there's one special thing about it. If you remember x minus 2, it looks like it's negative 2, and negative usually goes to the left. But it was minus 2, it shifted to the right 2. Plus 5 usually is right 5, but it actually went left 5. So it kind of goes the opposite direction of whatever it kind of looks like. And I'm going to write that word opposite under here as well. The opposite of what it looks like. Okay? So that's the effect that h has on the graph. Okay, the next thing I'm going to look at is I'm going to go back and let h be 0. I'm going to keep a 1, and I'm going to mess with the letter k here. Okay? And the first one I'm going to look at is x squared plus 3. Let's see what effect h has on the, k has on the graph. If I go x squared plus 3. And if I press graph, what it did there is instead of the vertex being at 0, 0 with the parent function, it looks like it bumped it up 3. Okay? What if I did this one? What if I did y equals x squared minus 4? Just like you might think, if it's minus 4, if I press graph, it looked like it shifted it down 4. And I think we're getting to the conclusion here. What effect does h have on the graph? I'm sorry, I keep saying h. What effect does k have on the graph? K shifts the graph up or down. Shifts it up or down. Now k is normal. If it's a positive 3, it's going up 3. A negative 4, down 4, and so on. Okay, so that's just what it looks like. And then lastly here, what about the letter a? Okay, I'm going to let h and k both be 0, but I'm going to mess with the letter a out here. Okay, and most specifically, if I go back to the parent function, I'm going to let a be a negative 1. Okay, so I'm going to type this equation, y equals negative 1x squared. And let's see what effect a has on the graph. If I go negative 1x squared. And what that did, It didn't shift it at all. The vertex is still at 0, 0, but it opens down instead of opening up. Okay? So that's the major thing that we're going to concentrate on here with this. A is going to tell if it opens up or if it opens down. It'll open up if it's a positive number, and it'll open down if it's a negative number. Okay, we'll see later here that A also affects the graph a couple different ways, but for now we're just going to concentrate on whether it opens up or down. Okay, so there's some different variations of a quadratic equation. And like I said, the one we're going to work with is vertex form. Okay, we're going to do some graphing here shortly in just a couple minutes. Okay, and we know that the most important point on a graph is the vertex. Well, there's a reason why this is called vertex form. Okay, and the reason for that is we can identify where the vertex is just based on its equation. And to kind of summarize it here, the parent function is the regular one, and that's vertex, its vertex is always at 0, 0. But if it has an h and a k going on here, it's just going to shift that vertex left or right and up and down. And we can do that, or we can find that vertex by identifying what h and k are. So that's where the vertex is going to be. And remember the special thing about h? H is always the opposite of what it looks like. Okay, so in the next slide here, I'm going to give you a couple different equations, and we're going to try to identify the vertex. Okay, just the vertex, that's all we're going to do. So here it is. Find the vertex of each of these. Okay, and what we're looking for is we're looking for an h and a k. Well, there's the h, there's the k. And h is the opposite, so it's minus 3. It's actually going to go positive 3, positive 2. Right 3 and up 2 is where that vertex is going to be. This one also has an h and a k. There's this h, it's plus 4, but it's the opposite. So we're going to go negative 4, negative 7. If you look carefully at this one, okay, it has an h, x minus 5, so it's going to go right 5, but there's no k out there. And we know from a few minutes ago, if there's no k out there, technically it's plus 0. So it's at 5, 0. That one's just going right 5, up 0. And if you look carefully at this one, okay, it has a k, it's going down 4, but it doesn't even have parentheses. Well, technically, it's x minus 0 squared in parentheses, and its h is 0. It's over 0, down 4. Okay? So when we graph these here in just a minute, we're going to want to be able to identify and find out where the vertex is. And if we can identify h and k, we can find at least one point, the most important point on our graph, fairly quickly. Okay? All right, and here's how we're going to graph an equation once it's in vertex form. We're just going to take a look at one of these. Okay, there's an equation. Okay, and we're going to use that equation to identify the vertex. Okay, and this one does indeed have an h and a k. It's over 2, right 2, up 4. Okay, so if I was to make a sketch, or if I was to use my graph paper, it's going to be right there. There's my vertex. And in the back of my mind here, I'm going to look at the a out front. Does it have an a out in front? It sure does. And it's a negative 3. Because it's negative, that tells me that this thing is going to open down. Okay? Well, I can't just draw an upside down curve, or a U. Okay? We're going to use the table. We're going to go to the calculator and use the table to find its vertex. Okay, so if I grab my calculator, and I go to type in this equation, negative 3, parenthesis x minus 2 squared plus 4, and I hit the graph of it. Okay? And I can see its graph right there. Does it look like the vertex is in the right spot at over 2, up 4? It sure does. It's right there. Okay, and like I said, I want at least a couple other points, as many as we can find on either side of the vertex. And the place we're going to find that is on the table. If I go second graph and go to my table, okay, if the vertex is a nice number, which it will be most of the time here, I like putting the vertex kind of right in the middle of my screen. And then I try to find a couple points above it and a couple points below it. And like we said before, we typically go up to the numbers in between negative 10 and positive 10. Okay, but there's a couple of them. I could do 1, 1, over 1, up 1, over 0, down 8, down there, right 3, up 1, and over 4, down 8. Okay? And then I would connect them with a curve, something like that. Okay? But like I mentioned before in previous lessons, when you're making these graphs, make sure I can see the points on them. Okay, I have to see the points. You get the points right from the table. Do you necessarily have to copy the table down onto your paper? No. Okay, you can simply copy them from your calculator. Like I said, this one did have two nice ones on either side before the numbers start getting big. Sometimes you might only be able to find one on either side of the vertex. Sometimes there might be more. Sometimes there might be halves. You can certainly graph 4.5, 3.5, and so on. Okay, but graph as many points as you can. That's going to make your graph be more accurate. Okay, so that's how we're going to graph them. Find the vertex, use the calculator. Excuse me. Okay, the next part here is a little bit trickier. Okay, we're going to convert from standard form to vertex form. Now, back in Google Classroom, okay, on section 4.7, right down below this video, you'll find a little tab that says Extra Notes. Okay, and what I did is I took a picture of this and added it to it. It might not be a bad idea to print that off or make reference to that as you're going through this and rewatching the video here and looking at these next couple examples. Okay, but here are the steps that we're going to use to convert an equation from standard form to vertex form. Okay, and I'm going to do an example here right along with this as we do it. Okay, so I have 4 of them here, and they're all, well, 2 of them are the same. We're going to try to do 2 of each so we get some practice at it. Here's the first one though. It says y equals x squared plus 6x minus 5. Now that is definitely in standard form. Okay, and if I read step number 1 here, okay, what we're going to do with this is we're going to group the x terms together on one side of the equation and put them in parentheses. So here are my x terms right here. I'm going to group the x's together in parentheses. I'm not going to move the 5 over. We're going to keep everything in its spot. Okay? And it says, note the a, the number in front of x squared must be a 1. Now there isn't a number there, but so that means it's 1. So we're all good. Okay, we'll see here in a minute. If it's not a 1, then we have to do something with it. Okay? If you remember from the previous lesson called completing the square, okay, where we did half of b and we squared it and added to both sides, this is going to be very, very similar. And that's what it's talking about in step number 2. It says to take half of b, square that number, and add it to the x terms inside the parentheses, and subtract it from the constant term outside of the parentheses. Okay, now that kind of contradicts. We add it here and subtract it here, but think about this. If I have an equation and I want to keep it balanced, okay, and I have an equal sign, if I add 5 to this side, I have to add 5 to that side in order for it to be balanced. But the way that this is working is, instead of adding it to both sides, I'm going to add something to the right here, but to keep it balanced, I have to subtract it at the end. So I add it, but then I'm going to subtract it. And that's kind of what's going on here in step number 2. Okay, so let's try this one. Okay? X squared. Now, x squared plus 6x. And what it says here, I'm going to take half of b. Well, b is 6. Half of 6 is 3. I'm going to square 3, which is 9, and add it to the x terms inside the parentheses. So I'm going to add a 9. And again, where that 9 is coming from half of 6, which is 3. Whoops. And then I have to square it to get 9. Okay? But because I added 9 here, I have to subtract 9 from the constant out at the end. Okay? That's where this 9 comes from. I had to subtract it. Okay? And if I do the subtraction, negative 5 minus 9 is negative 14. Okay? So there's step number 2. Now step number 3 here is, it says to factor this stuff inside the parentheses. Okay, if you remember factoring, I have x and x. I need the factors of 9 that give me 6. Well, 9's a perfect square, so I'm going to use 3 and 3. And if they're both addition, if I do 3x plus 3x, I get 6x. And if I look closely, x plus 3 and x plus 3, it's the same thing twice. It's going to be x plus 3 squared minus 14. And lo and behold, there's vertex form. Okay? And if I really wanted to be specific and I wanted to label the vertex would be at negative 3, negative 14. There's my h, and there's my k. Okay? So there it is. Okay? Writing it from standard form to vertex form. Okay, we're going to try another one here now that we have one under our belt. Let's try one more. Okay. Okay, here's a second one that we're going to try. It's y equals x squared minus 2x plus 4. Okay. So it's in standard form. We're going to group the x's on one side. So here are my x's, and I'm looking out front here. There's a 1 in front of the x squared, so that's a good thing. So I don't have to worry about that again. Okay. But the next thing I'm going to do, I'm going to add something on the inside of my parentheses, and I'm going to subtract it on the outside of the parentheses. Here's another way of showing that. Okay, well, what number am I going to add on the inside of the parentheses? Okay, it says I'm going to take half of b. Well, b is 2. Half of 2 is 1. I'm going to square it. 1 squared is 1. And I'm going to add that 1 to the inside of the parentheses. I'm going to add it. But because I added it here, I'm going to subtract it. Oops. I'm going to subtract the 1 right here. Subtract 1 at the end. Okay? So here's what I have. I have x squared minus 2x plus 1. And 4 minus 1 is 3. So there I've just completed step 2. Now step 3 says I want to factor this into 2 parentheses. I can do x and x. The only factors of 1 are 1 and 1, and how do I get a negative 2 out of that? Well, think if I did minus 1 and minus 1, I get minus 2. And right down here at the end, I get x minus 1 squared plus 3. This is the same thing written twice, so I can write it as that quantity squared. And there's my vertex form right there. Okay. All right, so hopefully it's not too terribly bad. Okay, but the nice thing about these first 2 problems is there wasn't a number in front of the x. Okay? Well, that brings us to our next example. What if there is a number in front of the x? Okay, let's try one of these ones where we have something going on out there. Okay, what if I had y equals 2x squared plus 8x minus 3? Oops. 2x squared minus 8x, rather, plus 3. Okay, well, we're going to do the same thing. We're going to go through the same steps. Step 1 says to group the x's together. Okay, there it is. Okay, but this time now there's a 2 there. Okay, well, I don't want a 2 there. We can't have a 2 there. So the way I get rid of it is I'm going to take the 2 and I'm going to factor it out of just the x terms. Okay, so I'm going to take a 2 out. And what's left over if I divide out a 2? I get just an x squared minus 4. Okay, x squared minus 4. Okay. Whoops. I forgot minus, there we go, minus 4x. Okay. Oh, where did I mess up here? Okay, yep, we're okay. So next, the next thing we did in step 2, now we're going to factor it. So I'm going to have y equals 2 times x, not factor, but we're going to add something. Minus 4x. I'm going to add something to the inside of the parentheses. And then I have my plus 3. And then I'm going to have to subtract something outside the parentheses. Okay? Well, what's going to go in this little red bubble here? It's going to be half of b, which is 2. 2 squared, I have to square it, is 4. Okay? That's what I'm adding to the inside of the parentheses. But now this is where the game changes a little bit. I don't simply subtract 4. And take a look at this. If I look here, I had this 2 out in front. And if I distributed everything through here, what number did I actually add right over here? I actually did 2 times 4. I actually added 8. Okay? And the way I counteract or get rid of a positive 8 is I have to subtract 8 out there at the end. Okay? So long story short, when we factor out something, it becomes a multiplier to the number that I added inside the parentheses. Okay? If I keep going here, I'm going to factor this stuff. I can do x and x. Okay, and it turns into a minus 2 and a minus 2. Negative 2 and negative 2 get me my negative 4. And out here at the end, I get negative 5. Okay? And because these two things right here are the exact same thing, I can rewrite them as x minus 2 squared minus 5 equals y. And there's my vertex form. Okay, so that got to be a little tricky with that multiplier. Okay. All right, we're going to try one more of these when there's a common factor or a coefficient up there in front of the x. Try one last one, and then we'll move on to the last thing. Okay. And again, this takes a little bit of practice, but once you kind of get the hang of it, it's not too terribly bad. Okay? All right, here's my third and final one, or fourth and final one. Okay, if I have this, y equals negative 3x squared minus 18x plus 10. Okay, now I even have a negative number out in front out there. Okay, Okay, well, let's do the same thing. Step 1 says I group my x's. There are my x terms. Oh, there's a coefficient in front of the x squared, and this time it's a negative 3. Can't have negative 3 there, so I'm going to factor it out again and again of just the x's. If I divide out a negative 3, I'm going to get x squared. This is going to turn to plus, and negative 3 divided by negative 18 is positive 6x plus 10. Okay? So there I've completed step number 1. Okay? Now when I go to step number 2 here, this is where I'm going to add something to the inside of my parentheses. And I have my plus 10, but we're going to subtract something from the outside of the parentheses. Okay? Let's figure out what that number is going to be here. Okay? First of all, I need to figure out this one. And where this number comes from, it's half of b, which is 3, and I square it again, which is 9. So I'm adding a 9 right there in the bubble. Okay? But instead of subtracting a 9 out here, actually, what number did I add here? That multiplier, negative 3 times 9, I actually added a negative 27. Okay? So to help me fix that, I'm going to subtract a negative 27. And you guys know that subtracting a negative actually goes to add a positive. Okay? So you see how that turned into a plus 27? Because there my multiplier was negative 27. To counteract a negative 27, I add 27. Okay? The last thing we did here is we factored this into x and x plus 3 and plus 3. 3 and 3 get me 6. 10 plus 27 is 37. Okay, and once again, because these two are the same thing, I can write it as x plus 3 squared plus 37. Okay, and there's my vertex form, I should say. And if you look carefully, the vertex would be at negative 3, positive 37. Okay, so that's going from standard form to vertex form. A couple examples, but I hope that helped clarify things, and I think I kind of covered all the ones that you're going to see. Okay, there's one very last thing that's in this section that we're going to see, is they're going to give us a graph. Okay, and we're going to have to write that equation in vertex form. So our goal is to go to vertex form given a graph. And this is also in the Google Classroom. On the extra notes, I put a copy of this in there so you can print that off if you want to or have it to look at. Okay, but what we're going to do is we're going to identify the vertex and write it in the equation. And the key here is we're going to find a. Remember, so this is our goal. Maybe I should write this. Okay, from the graph, we're going to know the vertex. So we can plug in the numbers for h and k pretty easily, as we'll see here in a minute. But then there's one last letter that we have to find. And the way that we're going to find that a is they're going to tell us another point somewhere on the graph, and that some other point has an x-coordinate and a y-coordinate. Okay? We're going to take the x-coordinate and plug it in for x, and the y-coordinate and plug it in for y, and we're going to solve for a. And then we're going to rewrite our equation with all 3 letters in it. Okay? So that's kind of the plan here. Okay? I'm going to turn the page here in a second. Okay? And let's see if we can do that. Okay? So here we go. I have 2 last examples, and then we're done. Okay? All right, so here we go. there's a graph. This is our goal. We're going to try and write that equation with A, H, and K in it. And as I said, the first thing we're going to do is we're going to identify the vertex. The vertex is right here. It has an H and a K. Okay? If I write that 3 and the 2 in my equation, I'm going to get something that looks like this. A times x minus 3 plus k, which is 2. And notice it's x minus 3. Okay, it would go to the right 3, making it positive 3. So I'm 2/3 of the way there. The last thing I have to find is this a. Okay? And as I said before, there's another point here. It has an x coordinate and a y coordinate. We're going to take that -1 and -2 and plug it in for x and y. Okay? So for my y is going to be -2. I'm going to have -2 equals a times x, which is -1 minus 3 squared plus 2. Okay, so kind of what I do is I plug the -1 in for x and the -2 in for y way over there. And now I have that equation. Can I solve it? Let's do a little simplifying first. If I do the stuff in the parentheses, -1 minus 3 is -4. -4 squared is 16, positive 16. So I end up with 16a plus 2 is what I'm looking at. Okay, let's keep solving for a. If I move my 2 over by subtracting 2, -2 minus 2 is -4 equals 16a. And then I divide by 16. And I get -4/16. Well, what can we do with -4/16? We can reduce it, and that would reduce down to -1/4. Okay? And there's the a that I'm looking for. And what do I do with that a? I put it in my equation right there. And my grand finale answer is going to look something like this. Y equals -1/4 x minus 3 squared plus 2. Okay, so these problems aren't too terribly bad. Okay, finding the h and k part of it should be pretty easy. And we have to do a little bit of substitution to solve for a. Okay, here's the very last one for the day. Okay, let's give this a whirl. Here's my goal. I always kind of like writing this down to start with. Do we know the vertex? The vertex is way down here at -1, -2. So I'm going to write my -1 in for h and my -2 in for k. And my equation is going to be like this. A x minus -1 squared plus -2. If I plug in the h and the k up here in my equation. Okay? All right, well, let's simplify that a little bit. A times x plus 1 squared minus 2. Again, I get a change right there. Okay, so I have my h and the k in there. Lastly is we have to find this letter a. And the other point that they have on the graph up here is -4/13. That's an x coordinate and a y coordinate. If I take that and plug it into my equation for x and y is 13, x is -4, minus 2. And let's simplify and solve. -4 plus 1 is -3. Oops. -3 squared is 9. This turns, oh shoot. This turns into a 9a minus 2. I think I did -3, yep. Okay. If I add 2, okay, if I add 2 here, I get 15 equals 9a. And then divide by 9, and I get 15/9. Okay. I think I did that right. -3 squared is 9. Yeah. If I simplify, divide each by 3, I get 5/3. Thinking I did that right. 13, -4 plus 1 is -3, which is 9. Yep, I think I'm okay. And my grand finale answer, 5/3 x plus plus 1 squared minus 2. Okay. All right, there we have it. Thanks for tuning in.